And now we're going to close the course with my favorite application. We are going to plot the Julia set. The Julia set is a fractal geometry object where we can observe chaotic behavior inside a dynamical system. And we've chosen this example to show you the applications of complex numbers on NumPy. The first thing that we're going to do is declare a complex number. This number will determine the shape of the Julia set. Let's initialize this complex number as 0,835 for the real part and -0,2321 for the imaginary part. And now we're going to create two arrays that will represent the x-axis and the y-axis. And we'll do that using the Linspace method from NumPy. We'll choose the range from -2 to +2 for both the x and the y-axis. And we want 1,000 elements for each one, and the same thing for y. Now, we're going to use the meshgrid function, passing the x and y arrays, and this function will take the values of the x-axis and the values of the y-axis, and it will return a grid with the position of every point on the plane created by the x and y arrays. That is, the meshgrid function returns the points that we get combining each value from the x array and each value from the y array. And on top of this grid, we'll be able to plot a complex function. Let's execute this cell and let's see the shape that this grid has. As you can see, the result of calling meshgrid will give us a 2000 by 2000 grid for the x and the y-axis. Now, the function that we're going to plot on this mesh grid will be stored in the z variable. And we'll initialize it as an array of complex numbers where the real part is the value of x and the imaginary part is the value of y times 1j. We do this to convert the z array into an array of complex numbers. And the result that we're going to see graphically, that is the Julia set, we are going to store it in the result variable that will initialize as an array full of zeros with the shape of z. And we are going to create an array that will work as a mask. That is, it will allow us to decide which points of the grid are part of the Julia set or not. And based on whether those points belong to the set or not, we can let NumPy apply a function to them or not. Let's create an array filled with ones with the shape of z, with the difference that now the data type of this array will be Boolean. That is, we want an array with true and false values. And now we're going to iterate for a certain number of times. Let's pick 24, for example, which means we want to repeat this operation 24 times. And inside the loop, we are going to update the z function in the points that the mask evaluates as true by raising the value of those points to the second power. And we'll add to the result our complex number. Then we'll update the values that the mask evaluates as true in this way. We'll find the absolute values of the elements in the C array, and the ones that are smaller in absolute value to 2 will remain true, and the other ones will become false. And the final thing we'll do is take the result array and add to it the values of the mask. Let's execute this cell, and now it's time to finally graphically see the Julia set. For that, we create a new plot using Matplotlib, calling plt.figure, and giving this new figure a size of 12 by 12, and then we'll call the imshow method, giving it as argument the result array. And we'll also give this function an argument called extend, where we'll write the location of the borders of the image as a tuple, like this. And now it's time to choose the colors in which we want to see our plot. We do that by passing the cmap argument and setting it to cm.gnuplot2. And next, let's remove the axis from this plot. We do that by calling plt.axis and passing a string as argument called off. Alright, now let's execute this cell, and here it is, the Julia set. It's a fractal geometry object that appears in some dynamical systems and encapsulates regions of chaotic behavior. And that's it. With this beautiful image, our course is over. I hope you had a good time, that you learned a lot, and don't forget that in the description we left a link where you can check out all our courses, along with another link to our latest course on reinforcement learning. It's been a pleasure having you with us, and I'll see you next time.